your teacher in Technology and Livelihood Education. You can call me Ma'am Sales or Ma'am Miles. For today's lesson, you are going to learn how to make a LAN cable. So what is a LAN cable or Ethernet cable? An Ethernet cable is a common type of network cable used with wired networks. Ethernet cables connect devices such as PCs, routers, and switches within a local area network. How about computer networking? What does it mean? Computer networking refers to connected computing devices such as laptops, desktops, smartphones, and other devices that communicate with one another. These devices are connected through wired or wireless network. Wired network, also called Ethernet network, is the most common type of local area network. It uses cables to connect computers and other networking devices. There are three types of network cables used in computer networking: the coaxial cable, twisted pair, and fiber optic cable. Among these cables, the most commonly used cable is the twisted pair. In this lesson, you will learn how to make an Ethernet cable based on Electronic Industries Alliance Telecommunications Industrialization Standards using unshielded twisted pair cable. For your first activity, I want to know what you already know about this lesson. So I want you to answer the following questions. You can select your answer from the given choices on the screen. Number 1, it is an 8-bit standardized physical network interface for connecting telecommunications or data equipment. What is your answer? Very good. That is RJ45. Number 2, it is a type of twisted pair cable that is used in structured cabling for computer networks such as Ethernet. What is your answer? Very good. That is UTP cable. Number 3, it is a handheld device used to strip the electrical insulation from electrical wires. What is your answer? Very good. That is wire stripper. Number 4, it is an electronic device used to verify the correct wiring of connectors on the cable. What is your answer? Very good. That is LAN cable tester. Number 5, it is used to connect devices of different types such as a computer to a router. What is your answer? Very good. That is the straight-through Ethernet cable. Those who were able to answer the pretest correctly, that is good. That means that you already have the prior knowledge of this lesson. And for those who cannot answer the pretest, it's okay. You will learn it from our discussion. Just listen carefully. In making an Ethernet cable, there are color codes to follow. We have 568A and 568B. In 568A, it follows the order from white-green, green, white-orange, blue, white-blue, orange, white-brown, and brown. And for 568B, it follows the order from white-orange, orange, white-green, blue, white-blue, green, white-brown, and brown. So those are the two sets of colors that we can use in making an Ethernet cable. There are two types of Ethernet cable wiring. Number one is straight-through Ethernet cable, which is used to connect devices of different types or dissimilar devices. For example, computer to a router. And the table on the screen shows the wire positions of the straight-through cable on both sides. So on side A, it follows the order of green-white, green, orange-white, blue, blue-white, orange, brown-white, and brown. And on the other side, it follows the same. So it uses the same color code, that is 568A, but you can also use 568B. Make sure that you only use the same color code for both sides. A straight-through cable is used to connect the following devices. For example, PC to switch, PC to hub, router to switch, switch to server, hub to server. And the other type of Ethernet cable wiring is what we call crossover Ethernet cable. Crossover Ethernet cable is used to connect devices of the same types, or what we call similar devices. For example, computer to a computer. And in crossover cable, it uses different color codes. So if you use 568A on the first end of the wire, you need to use 568B on the other end of the wire. So the table on the screen shows the wire positions of the crossover cable on both sides. On side A, it follows the order of colors from green-white, green, orange-white, blue, blue-white, orange, brown-white, and brown. So that is 568A. And on side B, it follows the order of colors from orange-white, orange, green-white, blue, blue-white, green, brown-white, and brown. So that is 568B. So those are the things that you need to remember in making a straight-through and crossover cable. And in addition, for crossover cable, a crossover cable is used to connect the following devices. For example, two computers, two hubs, a hub to a switch, a cable modem to a router, and two router interfaces. So please be reminded that straight-through cable is used in connecting dissimilar or different devices, and crossover cable is used to connect similar devices. Before we proceed to the step-by-step procedure in making a LAN cable, let us discuss first the tools and materials needed in making a LAN or Ethernet cable. Number one is the register jack, or what we call RJ45. RJ45 is an 8-pin standardized physical network interface for connecting telecommunications or data equipment. Number 2 is the UTP cable category 5E. UTP cable category 5E is a type of twisted pair cable that is used in structured cabling for computer networks such as Ethernet. Number 3, wire stripper. Wire stripper is a small handheld device used to strip the electrical insulation from electrical wires. Number 4, RJ45 crimping tool. RJ45 crimping tool is a tool that is designed to crimp or attach a connector to the end of a cable. And the last one, LAN cable tester. LAN cable tester is an electronic device used to verify the correct wiring of connectors on the cable. So those are the 5 tools that we need in making a LAN or Ethernet cable. Now that you already know the different tools and materials needed in making a LAN cable, We can now proceed with the step-by-step procedure on how to make a LAN cable or Ethernet cable. The following are the steps in making a LAN cable. Number 1. Unroll the required length of network cable and add a little extra wire. If a boot is to be pitted, do so before stripping away the sleeve and ensure the boot faces the correct way. Please note that the cable length should not be more than 100 meters to prevent attenuation. Attenuation is the degradation of signal strength due to losses as signal travel down the length of the cable. Keeping the length within 100 meters from the access point to the patch panel or network switch will ensure good signal strength or quality. Step number 2. Carefully remove the outer jacket of the cable. Be careful when stripping the jacket as to not nick or cut the internal wiring. One good way to do this is to cut lengthwise with snips or a knife alongside of the cable, away from yourself, about an inch toward the open end. This reduces the risk of nicking the wire's insulation. Locate the string inside with the wires, or if no string is found, use the wires themselves to unzip the sheet of the cable by holding the sheet in one hand and pulling sideways with the string or wire. Cut away the unzipped sheet and cut the twisted pairs about 1 1/4 inches. You will notice 8 wires twisted in 4 pairs. Each pair will have one wire of a certain color and another wire that is white with a colored stripe matching its partner. This wire is called a tracer. Step number 3. Inspect the newly revealed wires for any cuts or scrapes that expose the copper wire inside. If you have breached the protective sheet of any wire, you will need to cut the entire segment of wires off and start over at step 1. Exposed copper wire will lead to a crosstalk, poor performance, or no connectivity at all. It is important that the jacket for all network cables remains intact. Step number 4. Untwist the pair so they will lay flat between your fingers. The white piece of thread can be cut off even with the jacket. For easier handling, cut the wires so that they are 3/4 inch long from the base of the jacket and even in length. Step number 5. Arrange the wires based on the wiring specifications you are following. There are 2 methods set by the TIA, 568A and 568B. 568A starts from white-green and 568B starts from white-orange. Which one you use will depend on what is being connected. A straight-through cable is used to connect 2 different layer devices, for example, a hub and a PC. 2 like devices normally require a crossover cable, for example, PC to PC. Step number 6. Press all the wires flat and parallel between your thumb and forefinger. You need to verify the colors if they have remained in the correct order. Then, cut the top of the wires even with one another so that they are 1/2 inch from the base of the jacket, as the jacket needs to go into the RJ45 connector by about 1/8 inch, meaning that you only have 1/2 of the room for the individual cables. Leaving more than 1/2 untwisted can jeopardize connectivity and quality. Ensure that the cut leaves the wires even and clean. Failure to do so may cause the wire not to make contact inside the jack and could lead to wrongly guided course inside the plug. Step number 7. Keep the wires flat and in order as you push them into the RJ45 plug with the flat surface of the plug on top. The white-orange wire should be on the left if you are looking down at the jack. You can tell if all the wires made it into the jack and maintain their positions by looking head-on at the plug. You should be able to see a wire located in its hole, as seen at the bottom right. You may have to use a little effort to push the pairs firmly into the plug. The cabling jacket should also enter the rear of the jack about 1/4 inch to help secure the cable once the plug is crimped. You may need to stretch the sleeve to the proper length. And don't forget to verify the sequence if it is still correct before crimping. Step number 8. Place the wired plug into the crimping tool. Give the handle a firm squeeze. You should hear a ratcheting noise as you continue. Once you have completed the crimp, the handle will reset to the open position. To ensure all pins are set, some prefer to double crimp by repeating this step. Step number 9. Repeat all the above steps with the other end of the cable. The way you wire the other end will depend on whether you are making a straight-through cable or a crossover cable. Please be reminded that a straight-through cable is used to connect dissimilar devices, and crossover cable is used to connect similar devices. Step number 10. You need to test the cable to ensure that it will function in the field. Miswired and incomplete network cables could lead to headaches down the road. In addition, with power over Ethernet making its way into the marketplace, cross-wire pairs could lead to physical damage of computers or phone system equipment, making it even more crucial that the pairs are in the correct order. A simple cable tester can quickly verify that information for you. Should you not have a network cable tester on hand, simply test connectivity pin to pin. So those are the steps in making a LAN cable. I hope that you were able to follow these steps and that with this lesson, you will be able to make a LAN cable by yourself. To check what you have learned from this lesson, I want you to answer the activity on the screen. So for the direction, name the pictures in column B and match it to the descriptions in column A. Write your answers on a separate sheet of paper. So I will give you 3 minutes to answer this activity. Okay, time is up. Let us check your answer. So let us first name the pictures in column B, and then after that, let's find its description in column A. So letter A, that is a crimping tool. Letter B, that is a wire stripper. Letter C, that is RJ45. And letter D, that is LAN cable tester. And the last one, that is Ethernet cable or LAN cable. And for the function, let us match. Number 1, it is an 8-pin standardized physical network interface for connecting telecommunications or data equipment. That description is for letter C, RJ45. Number 2, a type of twisted pair cable that is used in structured cabling for computer networks such as Ethernet. So that is for letter E, Ethernet cable. Number 3, a small handheld device used to strip the electrical insulation from electrical wires. So that is for letter B, wire stripper. Number 4, an electronic device used to verify the requiring of connectors on the cable. That is for letter D, LAN cable tester. And number 5, a tool that is designed to crimp or attach a connector to the end of a cable. That is for letter A, crimping tool. For those who got a perfect score, congratulations! And for those who got only 3 and below, so you need to study more so that you will get a higher score next time. Okay, for your next activity, you need to rearrange the following procedures in their proper order. Use numbers to indicate the order of precedence. Again, write your answer on a separate sheet of paper. So I will give you 5 minutes to finish this activity. time is up again. Let us check your answer for self-check number 2. So, kindly check your answers. For number 1, it is the 8th step. Number 2, it is the 6th step. Number 3, it is the 4th step. Number 4, the 2nd step. Number 5, 10th step. Number 6, 1st step or 1. 7, 3rd step or 3. 8, 5th step or 5. 9, 7th step or 7. And the last one, number 10, is 9th step. So again, answer for self-check number 2 is 8, 6, 4, 2, 10, 1, 3, 5, 7, and 9. Congratulations to those who got a perfect score. For your performance, you need to create a straight through and crossover cable using the materials that we have discussed. And you will be graded according to the rubrics displayed on the screen. So for the criteria, accuracy is 50%, adherence to the procedures is 20%, workmanship is 20%, and speed is 10%, a total of 100%. Good luck! Okay, that's all for today. I hope you learned something from our lesson and that you are going to apply it. Always stay safe by following the health protocols. Don't go outside if not necessary. Again, I am your teacher in TLA, Ma'am Mylene Sales, and see you next time.